Hi everyone. Today we are going to explore a random strategy, a strategy where our entry points are random. I will teach you how to code this strategy in Python so that you can also profit from the market using this strategy, which relies on the volatility of Bitcoin. It relies on the fact that even if you have random entry points without technical indicators, you might be able to profit because the price will be higher than the buy price simply because of the volatility of Bitcoin. So let's dive into the strategy. First, I will explain the strategy and then we will see how to code this up in Python. As you can see, by using this strategy, I was able to make profits in various random simulations depending on how many Bitcoins I was allowed to hold in a given iteration of the strategy. So what is the strategy? Let's explain the strategy. So as I said, in this strategy, the entry points are completely random. We toss a coin, or basically we generate a random number, and if the random number is 1, that is a coin falls head, we buy. Now we set a take profit target. Let's say that take profit target is 1%. And then we set a maximum holding period. If we reach the if we reach our take profit target before the holding period, we sell at a profit. Otherwise, we just sell at market price. Let's see an example here. Let's say we decide to randomly buy Bitcoin somewhere around here. And in this case, because we bought randomly, we were not immediately lucky, and there is sort of a downtrend of the Bitcoin after we bought, as you can see here. So here we bought the Bitcoin at this position here, and then we can say that this is like the place where we buy, and then we decide to set a take profit target somewhere around like maybe 1% higher than where we bought the Bitcoin, so maybe somewhere here. That's our take profit target. And we also need to decide on how long we are allowed to sort of hold the Bitcoin, and that is a variable in our strategy. So in this case, we probably want to, let's see, okay, set some time period like this, which is our maximum holding time. So at the end of the day, the strategy says that we buy the Bitcoin here, and if in this maximum holding time, within this maximum holding time, we reach a take profit, which we reach somewhere here in this particular example, then we sell the Bitcoin. If we don't, and we reach till here and we still do not have our required profit, we sell the Bitcoin at a loss. We sell it at the market price, whatever the price is on the candle just right after our maximum holding time expires. So that is the strategy in a nutshell. So you might ask why the strategy works. So again, I've laid down the strategy here, and the strategy works because Bitcoin is volatile. So because of the principle of the reversion to the mean, it will reach somewhere close to where the buying price at some point during sort of the market life cycle, and it will reach a little bit higher than the market price, like our buy price, just by pure random chance. And that is what we are relying on in this strategy. So let's see how to execute this strategy in Python now. Here we import the required libraries, and then we download the historical Bitcoin data. So in this case, you'll have to use a key for accessing this website called Crypto Compare, where you can download sort of hourly Bitcoin data. You have to specify the symbols, and you have to specify how many data points. I think they allow you to a maximum of 2,000 data points, so that's what I downloaded here. And then there is some data cleaning steps to sort of clean the data and put it into a data frame. And at the end of the day, this is what it should look like. For each time period, we have the open, high, close, and low prices. Now, for your convenience, I saved it, the cleaned data frame into a file so that you don't have to do that work again. And these files are available from download in the description box below. So let's first check on the time period here. So as you can see, I looked at the first and the between two consecutive data points, and there is a gap of 3,600 seconds, which is basically 1 hour. So yeah, so that means that this is an hourly data, and then we did some data cleaning. So we convert the Unix time to a date and hour. So as you can see, we have like the date and then the hour, corresponding hour here. And then we have a way to sort of visualize the candlestick chart, which you can replicate when you download the notebook. But this, we look at a smaller section of the data frame, which is only like 10 days of data. And you can see the open, high, low, and yeah, you pass these to the function, and then you can basically plot the candlestick chart. So now let's come to the nitty-gritties of the algorithm itself. So as you can see here, we set a number of parameters in this algorithm. Even if this is a random algorithm, there are certain parameters that we have, which you can sort of play with and also optimize, which I have not done in this notebook, but for a future iteration, you can sort of optimize these parameters as well. So the first is the prop buy, which is the proportion of time the coin will fall ahead. In this case, it is 0.5, which means that this is like a fair coin. It will fall ahead like 50% of the time. But if you want to buy less or more, you can sort of set that by suggesting what proportion of the time the coins should fall ahead. The maximum hold time I've set to 24 hours. Again, that's just a starting point, and there could be sort of a more optimized number here. And here I've set the maximum number of Bitcoin buys to 5. So in theory, whenever the coin falls head, you can buy a Bitcoin, but then you need to have an infinite sort of cash in order to be able to do that, which we don't. So depending on how much cash you have, we've set the maximum number of buys to some number. And then we have to set what profit percentage we want. We have set at 1%. And so we loop through the data frame. We first get the current price. So we define two lists. One is the buy list and the sell list. And in the buy list, we will have all of the transactions that we currently have, but we haven't sold them yet. Once we sold them, we will add to the sell list. So there is a catch here that, or sort of a nuance here, that we don't want to. We want to be able to change the buy list as if we sell Bitcoin, we want to be able to remove it from the buy list. So we are looking at the copy of the list so that we are able to remove the Bitcoin or transaction if we decide to sell it. So for each of the coins that we have already bought, for each of those transactions, we ask if we have reached the take profit. So if the high of the candle is larger than our take profit value, then we remove this from our buy list because we've decided to, or we've been able to sell the Bitcoin. But we're not selling it at the high of the candle. We are selling it at the sort of limit price that we had set because it was a limit order when we decided to sort of buy. So we sell it at the profit percentage multiplied by the buy price, which in this case would be 1%, so 1.01 multiplied by whatever our buy price is. So this is our sell price, and then we make a note of the time and index of the sell. And finally, we append that to the sell list. Now, the second thing we do if we cannot sell the coins in profit, we check for each of the items in the buy list. We are checking if we have exceeded the maximum hold time. In this case, again, we sort of decide to sell it. And finally, we generate a random variable using the Bernoulli it's a Bernoulli random variable. It's from the SciPy stats module. And one important nuance here is that we need to have a random state which changes with time. But we want it to be repeatable, so we use the time value of the row, and we add some number to it as our random state. So each time you run this, you'll have the same random state, so that the random variable produced will be repeatable, but in each sort of iteration, we want to produce a different random variable. And so if our random variable is 1, which is when the coin falls head, and if our buy list is less than the maximum number that we can buy, then we go and sort of append the buy list. So that is what the basic algorithm looks like. We ran one version of the algorithm. So we put everything down into sort of wrapped everything into a function where we can set all the parameters of this algorithm. And finally, we looked at one version where we were allowed to buy 10 Bitcoins at a maximum, but that would require a huge amount of capital, and we were able to sort of profit $15,000. Here we looked at what happens if we are allowed to buy only 1 Bitcoin, and you can see the individual transactions here. And we lost maybe like 3 of them, like here, this is a loss, this is a loss, and this is a loss. But the rest of the ones are profits. And we make a total profit of around $3,000. And here I sort of visualize some of the profits, and what you can observe is that, like, this is an example where we buy here during the green and we sell during the red, and we again decide to buy during this green circle and we sell in the red circle. As you can see, we decided to buy randomly, so we clearly bought into a case when the Bitcoin was sort of going down. But as you can see, by random chance, it sort of went up again, and we were able to sell at a profit before our sort of period, like maximum hold period. I think this is an example where we bought here, we were able to buy here and sell here, but then we bought the next one here, right here, and we weren't able to sell in the next 24 hours, and we sort of sold we had to sell at a loss here. But in most of the cases, we were sort of able to find a profit once we bought the Bitcoins. And that is the basic idea of the strategy using volatility. There's an extra section that I won't go through here, but this is fine. This is the example that I wanted to show you, where we were able to have random entries and still generate profits using using our rules of when we sell and take profit. In further videos, I will look at what happens in different regimes in the market, and also try to see if we can optimize some of these parameters. Thanks for watching, and please like and subscribe if you like what you see here. Thank you.